Today we'll try to understand rationalizing denominators. So mainly you're rationalizing only the denominator. So let's just take an example. 1 divided by root 2. So you're rationalizing the denominator. So in the sense, actually denominator is will be an irrational number, so you need to convert that into rationalize a rational number. So let's just understand how do we actually rationalize the denominator. So this is the denominator, that's a numerator. So if I want to rationalize this denominator, I'll multiply this whole fraction by root 2 and root 2. It's the same number. The reason why I am doing this here is there is only one term, so that's a term I'm actually going to use it here. Before this, what you need to understand is this particular value what we use to rationalize the denominator is called as rationalization factor. Understand that. So you might actually get some multiple choice questions based on what is the rationalization factor for this one. So root 2, it's a root 2 itself. So the reason why we are actually choosing root 2 is when we multiply this, denominator is going to be rationalized. So if I multiply 1 into root 2, it's actually going to be root 2, and root 2 into root 2, root 2 into root 2 is actually going to be root 4, and root 2 stays as is, can't do anything. Square root of 4 is 2, so that will be root 2 divided by 2. So we rationalize the denominator, just the concept. Rationalizing denominator, I'm actually finding the rationalization factor for the denominator, multiply and divide. So the reason why we are multiplying and dividing is that at the end of even if you verify this gets cancelled, this gets cancelled, the question whatever is given still stays the same. So that's the main thing. So now coming back to another example, 1 divided by root 2 minus 1. So if I want to rationalize this denominator, so I need to find out the rationalization factor for this. So rationalization factor for two terms in this, usually most of the time. So root 2 plus 1, I'm just going to change the sign of that. The reason why we are changing that sign, I'm going to rationalize the denominator. Once we do plus or minus or plus to minus, this is actually going to use the identity a square minus b square. What is the identity? If I expand this, it is a plus b into a minus b. That is a plus b, that's a minus b. A square minus b square, root 2 square minus 1 square, actually going to be root 2 square, that gets cancelled. So that will be 2 minus 1 is going to be 1. Understand the concept, very important. Now let's continue with another example. Root 3 minus divided by root 3 plus root 2. So rationalize the denominator. First finding the rationalization factor for the denominator, it's going to be root 3 minus root 2 divided by root 3 minus root 2. The reason why I did this is this has plus sign, I'm actually going to change this minus sign. This is actually going to make me use a square minus b square identity. So the numerator, if I'm going to multiply, that will be root 3 minus root 2 divided by root 3 into root 3 minus root 2. Remember this, the concept here is something like when you multiply monomial by binomial. This is just one term, these are two terms. This is a simple multiplication of monomial by binomial. Only thing is you might have variables, you might not have variables, but the concept is still the same. Or otherwise you can also think this as distributive property. Distributive property, what did we do in distributive property? A into b plus c was ab plus ac. I used to multiply this and I also used to multiply that, and the sign goes there. If it is minus, that's going to be minus, depending on the signs given. So now coming back to this question, now what happens, the bottom part a square minus b square, which is root 3 square minus root 2 square. That gets cancelled, that gets cancelled. That will be 3 minus 2, which is 1. So the only numerator is left, root 3 into root 3 minus root 2. Let's just use distributive property, root 3 into root 3, this into this, and again this into this, again minus root 3 into root 2. Root 3 into root 3 is 3, root 3 into root 2 is 6. So that will be 3 minus root 6. If the same question was asked in a way that represent this in the form of a plus b root 6, we have already brought that problem into this form. I can straight away say a is equals to 3 and b is equals to, there is nothing here, so nothing is here, in the sense there is 1, but they are asking plus. So if I am going to rewrite this, it will be 3 plus of minus root 6 minus 1, nothing is there, it's 1. So if that is a, that is plus, and b will take the value of minus 1, b will be equals to minus 1. Let's understand some of the things you need to remember for addition and subtraction for mainly roots, mainly the surds. So let's just understand these concepts. Root 2, root 3 plus root 3 is actually going to be 2 root 3. These are operations. Usually they come under operations on surds. Or if I take out root 3 as common, what will be left? There is 1, there is 1, that's 1 plus 1 is actually still going to be 2 root 3. Same thing goes with subtraction. When it comes to multiplication, root 2 into root 2, these are called as, or here, even here actually, these are called as like surds. What are like surds? If it is an algebraic expression, 2x plus 3x square minus x, this and this are like terms. Similarly, the one which has the same root with the same value, is actually going to be like surd. So that's the reason I'm actually performing that operation. If it was 2 root 2 minus root 3, these two are different, so I cannot perform any operation, it stays as is. So coming back to multiplication, you just multiply as long as that power, that root is actually going to be same. This will be 2 into 2, which is going to be root 4, square root of 4 is 2. That's what I wrote. Or otherwise you can write it as root 2 whole square, a into a square, root 2 into root 2 square. So if you cancel that, still be same. Root 2 into root 3, multiply whatever is inside, just root 6, as long as this and this stays same. If this is cube root 3 plus square root 2, these two are different, so I cannot do any operation here, multiplication, sorry, I can't do anything, I just have to keep it as is. Division is also same, so you can only cancel root 3, cancel, root 2 divided by root 3, you can't cancel, but you can actually write it as root 2 by 3, still the same. If I separate it, it will be different. So let's try to solve one of the questions and try to understand this a little bit more. Root 2 plus root 3 divided by 3 root 2 plus 2 root 3, you need to show that in the format of p plus q root 6. So now let's try to solve this. First thing to do is, I can see that there are irrational numbers, so I need to rationalize the denominator because nothing is there here. So rationalize the denominator. To rationalize the denominator, what am I going to do? I'm going to write rationalizing factor. Rationalizing factor, like we have understood in this scenario, is going to be 3 root 2 minus 2 root 3 divided by 3 root 2 minus 2 root 3. That sign has changed. Even if I cancel this, the question stays the same. So let's multiply these ones. I'll multiply this step by step. Just let's try to understand this. So that will be root 2 plus root 3. Put the brackets because this is going to be multiplication of binomial. 3 root 2 minus 2 root 3 divided by a plus b into a minus b. This is actually going to be a square minus b square. 3 root 2 whole square minus 2 root 3 whole square. Before I perform any operation on numerator, just let's look at the denominator. 3 root 2 whole square is 3 square and into root 2 whole square. That gets cancelled, so only 2 will be left. 3 square is 9. 9 2 is 18. Similarly, what happens? 2 root 3 will be 4 into 3, which is going to be 12. So now here root 2 plus root 3 and 3 root 2 minus 2 root 3. I'll just write this steps so at least you know. 18 minus 12, anyhow it's going to be 6. We'll put that in the next step. Multiply this. So root 2 into 3 root 2 minus 2 root 3, and then I have plus root 3 into 3 root 2 minus 2 root 3. Yeah, now it's done. Good, that is plus divided by, I have 18 minus 12 is 6. So if I multiply this, what is going to happen? Nothing is there, it's 1, and also sign is plus. 3 into 1 is 3, root 2 into root 2 is 2, plus into minus, minus, 2 into 1 2, root 2 into root 3 is going to be root 6. Plus into plus is plus, nothing is there, it's 1. 3 into 1 is 3, root 3 into root 2 is root 6, plus into minus is minus, then 1 into 2 is 2, root 3 into root 3 is square root of 9, which is 3, divided by 6. So 3 2 is 6 minus 2 root 6 plus 3 root 6, that will be minus 6, divided by 6. Minus 6 plus 6, they both get cancelled. So here if I am going to rewrite this, 3 root 6 minus 2 root 6 divided by 6. Remember, these two are like surds. They are like surds. Or if you don't want to go with the like surds, what you can do is take root 6 as common. Root 6 if I take common, what will happen? Here 3 is left, here's 2 is left. 3 minus 2 divided by 6. 3 minus 2 is 1, which is going to be root 6 by 6. If I am going to represent this as, p plus q root 6, all I have is root 6 by 6. Now even if I put plus, there is nothing here, so that means p is actually going to be 0. Q, what happens? Plus, I can take out root 6 because that's what is there, and whatever is left I need to put it here. That's 1 by 6. So if p is 0, q will be 1 by 6. Here they have asked for plus, q is 1 by 6. So that's our answer. P is 0, q is 1 by 6.